Wow. Well, nothing special tonight, except one thing. I'm going to try and label this one your demolition hammer and you. Well, I was talking with a former coworker and more than acquaintance and a friend. He's a friend that pops in now and then. About hammers. He was talking about an NPK, and I've worked with NPK, Tramac, Chicago Pneumatic, which is a different form of. Is that one? No, I don't know what CP is. Forgot that one. Stanley Hammers, which was NPK. The one I'm thinking of is Ingersoll Rand. They had some Tramacs relicensed. What they bought. What was the other? Oh, Indeco. That was one of the last ones I worked on. And Allied. So especially the old ones, 770Bs and such, 775Bs. Pretty decent size hammers. Well, anyway, I think in the Indeco I got up to, definitely had some 5,000s, 3,000s, some smaller ones, 2s, 15s, I think was the number. I don't remember the little ones too much. 750, and I think 1 500. So I've been through the gamut, but there was an 8,000. I don't think we ever had to do much of anything to the Indecos except hook them up, put a tool in occasionally, charge the accumulator, which isn't absolutely necessary for its operation, but it is for its smooth operation. It keeps the hoses from slapping. They're hydraulically operated, totally hydraulic. So warming up your hydraulics with an Indeco is almost more important than the others if you want the performance. But it'll work better cold than the others will. It's just one of those odd things. Well, what am I going on about tonight with the demolition hammers? Well, Lee was talking about having trouble. He checked into the hammer and said everything's fine, told them check their unit. They got angry, so then they called everybody down from the big guys, and management went down, and they're going on and on and on. Finally, they get the NPK company guys out there and said, well, turn your relief up. You're not even close. Well, it was a pretty good size hammer. We're talking in the 5,000 plus range. And when they're up there with an Indeco, and I think Allieds as well, but I'm not sure. Tramacs, I'm pretty sure they are. They have their own relief valve in them, so you have to set your auxiliaries high. What's the problem? Well, the problem is, well, there's twofold really. If the operating pressure of the unit itself, which is good to check sometimes, but the internal relief is a maximum on the hammer, so you don't really have to worry about that one too much. The one you have to worry about is on the machine. And 3,000 is kind of a minimum all the way across the board with almost everything. Operating pressure on these is different than relief pressure, and some people don't believe that. You look at the unit down in there, and they'll say at a flow, you'll have such and such an operating pressure. Well, you should check it. Hook up a gauge, and you want a fluid-filled gauge or a digital for sure. And while it's hammering, it'll give you a basic operating pressure, which is anywhere between 1,500 and 2,000, sometimes higher, 2,200 psi, 2,500. And what does that mean? The resistance within the hammer is that much pressure, and that's a driving force. Two different types of driving force, but we'll just stay there. That's the driving force. It's your hydraulics. And so some of you say, well, wait a minute, mine has accumulators some have accumulators to operate it. But that operating pressure can determine how fast that you get your return before it's released and the accumulator fires. Now, on those units, the slower the response, meaning if your operating pressure is high, which is on a lot of units adjustable, internal. Well, I say internal, it's a valve there usually. And you adjust the speed, the slower the speed with the same pressure is going to be a harder hit. Well, is generally a harder hit because it gives the accumulator and the accumulator type machines time to slam that thing down and then recycle it. So they generally hit harder. With Indeco, it's definitely true. The higher pressure, slower speed hits harder. It's just a fact of life. Piston is retracted further. It's not slapping down here because it can't fully stroke. But when it does full stroke, that's when your hammer hits the tool bit the hardest. So you have your operating pressure and your sometimes in the machine relief pressure, but always in the hammer on the machine itself, the carrier unit, that has its relief. Now, 3,000 pounds is generally a good figure on almost all of those things, not on a tamp. That's a different thing. We're talking only about demolition hammers. Another one is you've got your pressure coming in, whatever it says the pressure is operating at here, you want at least 300 psi on most machines, but as my buddy found out, his was 500 psi, and that's fine as long as you have a relief set for it. What's the problem? If they're too close together, and I've talked about this on Oliver tractors with closed center systems, it's a similar idea. The problem is that let's go back to the Oliver closed center system. The pressure compensator runs the pump, but every so often the compensator doesn't back off fast enough and you need that relief to squeak. Well, the hammer may have some trouble in it. They may pinch something or whatever, and there can be back pressure spikes, or it'll lock up. And if you have it lock up or back pressure spikes or whatever, then you need something to relieve on the machine at that point. But in between, while it's hitting, when the pressure builds up to cycle that thing, if it's not far enough apart by at least 300 pounds, and in this case the NPK 500, that relief valve can squeak. And it'll overheat that fluid so fast at that pressure and the amount of flow that's going through that hammer that your carrier unit will need a cooler. It cause big trouble. Well, it needs a cooler to operate at that relief pressure. You need to take your machine to carry your relief pressure up to 300 to 500 psi over, but you don't want it to go way over unless it says in their specs that crank that thing up. They'll tell you 300, 500, 1,000. So I've seen some units like a Tramac that had 200, 250, 300 psi difference, and the Tramac would not run. Go out there and crank it up to 400 or 500, suddenly the unit's running because its internal initial spike was higher than relief. Not the actual operating pressure, but to get it started took a lot. Once it was running, the pressure went down. It was one of the problems we used to have with Tramacs matched up on a machine. So you got your machine relief, you've got your flow rate set, and that'll change your operating pressure, what it takes to fire your unit and operate it. It may have a relief in it, but the relief is always set for maximum of that unit in the unit, if it has one. A lot of them under 3,000 with the Endecos did not have them. So keep that in mind with some of the others, that Tramac, NPK, Allied, they may have, what was the other one, Rockram, that's a copy, a mess. But any one of them may have an internal relief, but don't count on it. Make sure the machine is set proper. That's one. Pressure and flow, operating pressure. What's two? Two is what's your return pressure coming out. Very few of them will take as high as 350 pounds, but I have seen some. Your return pressure has to be very low, usually in the 150 or less range. I've seen some on the Tramac, they want 50 psi, and we could never get it. Even the only way to get it would be to have huge oversized hoses and go direct in the tank, so you're bypassing the cooler and the filter in some cases. No, we always tried to put it through the head of the filter. You do that, the filter's a restriction, you'll never get your 50 psi. But never run that unit without a filter in it, ever. The hammers tend to internally chip because of the way everything's moving in there, and the valves are clattering. So never, never, never run a hammer without a return filter somehow. Some of them have a return screen built on the carrier itself. So what's another one? Well, there'll be a setting on almost every machine, either a hand valve or setting in your monitor, to turn for one-way operation, which bypasses the main valve on return. I operate two-way all the time, and it always... Yeah, you're full. Shut up and listen. Like I just said, the return flow has to be low pressure at that flow rate. You say, yeah, but you can't. Yeah, you can. You pull out your flow rater. Flow it at that flow rate. You say, what? Fire everything up. Have all your valves open like they're supposed to be. The carrier valves. Your flow rater. Open it up and let it rip. Put it at the flow rate, 30, 40, 50 gallons per minute, whatever it is, or you can go liters per minute. But anyway, what's liters? Roughly 4 times whatever gallons per minute is. It's just a different number for the same flow rate. So 30 would be 120. 40 would be 160. And if you can't figure 50 out, I can't help you. You need to go to another video. So you put your flow rate on there, crank the machine up, and get fired up. You're checking your flow rate anyway because some of the monitors are not accurate, but most of your machines have good accurate monitors now. Set the flow rate and let it rip. And don't touch anything. Either you have to have a gauge attached, or usually there's a gauge on a flow rater, and that'll tell you your return pressure. Almost all of them operate someplace in the 100 to 200 pound range, and some will operate as high as 3 or 350 without a problem. But now you start into return restriction, you get heat. So once you got those all set, you make sure that on some of these machines they do have a nice screen and an accumulator even on the return side. But you have to be sure it's wide open. All right, back into your tank. Everything's all set, right? Not quite. Some of these have, what do they call it? ABF, anti-backfiring. Or anti-something. But the idea is you can't fire it unless there's pressure on the tool bed. Well, there's some of the new things anymore. Well, the funny thing is, in Deco, we were told would operate slowly even with the ABF. Said you could put a 3000 hammer and put a little mini on it and run some oil through it, and because it's hydraulic, the internal piston will actually move back and forth a little bit. It'll never hammer, but it'll move. I don't know if that'll actually do it with the ABFs, and the ABFs are on most of the bigger units. So you need a carrier to do something with it. Now, you've got it all set up, you're all there. Your return line cannot go through the valve, it has to go through the return. Some are set to go through the oil cooler. If there's not too much restriction, you can try that, but usually the pulses will crack the cooler. You can go through your main filter. It's nice to have a screen to catch the big pieces if the hammer disintegrates, but it sends chips and pieces through anyway in its normal operation. These things are low-hour deals and very high price. You don't get a lot of hammer for $80,000 anymore. So the screen helps catch the big pieces, and you want to run it through the return filter for certain. And if it isn't big enough, then you have to find a way to put a bigger one on there. That's going to be your main flow restriction. Number 2, if you have a size 12 JIC fitting or 12 ORB coming in, O-ring boss, to a JIC fitting that better be a minimum of 12, then your hose better be a number 12 or 3/4 nominal. It has to be, if not bigger. Now, I'm running out of time, so I can make it quick. On the return side, you will have a 16. But no, you will have a 16. But the fitting doesn't matter. On the return side, it's going to be a bigger port on almost 100% of the hammers, except some of the little guys. So if you have a 12 here, you're going to have a 16 on the other side. I've only seen a 14 once. It's on an Allied Tamp that was built in Germany. So don't go to 14s. So you have 12 on one side, 16 on the other, 16 and 20, 20 and 24. The return is always at least one side larger. So your hose needs to be that size larger going to the unit, the carrier. Well, yeah, but no, it doesn't matter what the carrier has. Your flexible hoses have more restriction than the steel pipes go into the back. So you need those to be full size. Well, we don't have that. What if I got 20 and 20 and it's 16 and 20? Cool. Seriously. If it's much one size bigger going in, just be sure it's not one size smaller. It can work, but that's something you do in desperation. Why? Because it causes heat. Check your hoses every so often, because they'll because of the way the things fold up, they'll pinch and crimp. If there's any pinch on them, any exposed steel, anything, replace the hoses. They take a big beating on there. That's a wear item. People, it costs us $500 almost every time we send it out. Yeah, well, you want to run the hammer safely or not? And there's a lot of environmental regulations that they see anything on that hose that resembles oil, even after you hooked it up, you're screwed. So, don't shoot the messenger here. All right, and now check your temperature on your hydraulics constantly while you're running these things. And then the other one is never pry with them, and always make sure that your hammer is vertical to what you're hitting on. If you're hitting on a surface like this, then turn it to hit it 90 degrees. And the other one is never hammer longer than 30 seconds. They like 10 to 15 seconds. to brap it 10, 15, 10, 15, and keep moving along to crack it. I know you're going to sit there and hammer for 3 minutes. That's stupid. It'll beat the hammer up. But that's what they'd like to do. It keeps the hammer alive a lot longer. When you cock things and push them apart, you take that bushing out in the bottom. The bushing, let me tell you, I've replaced a few. They're not fun. Even the easy replacers get peened in there. They're not fun to sit there sometimes for 2 hours welding them. And then to sit there for the next half hour with liquid nitrogen to put the new one in after you've cleaned up the entire body. You say put heat on the body, that'll help. Well, it might for a few seconds. But if that bushing doesn't go in, the heat that you just put in there goes into the bushing and warms it up faster than if it's just a cold room temperature here at the machine body versus the below sub-zero bushing. So those are the things to look at. They're pretty simple. Relief coming in, working pressure in the machine that's there, and your return. Those are your three main things to know. Your relief has to be 300 to 500 psi above the actual working pressure, which you'll check inside your book. Some of them will have an idea, and some you can check in the monitor even. Set your pressure and operate the unit. And if the unit doesn't operate, the two main things to look for are pressure coming in the relief and your return pressure. Because if you use your two-way and restrict anything on return, it won't hit, period. And some of them will go dat, and that's it. They won't do it again. They'll just stop. I don't know why, but they will, even with it relieved. If your valves tend to vibrate closed, well, make sure they don't. Your hose is pinched, make sure they don't. The hose is in the back pinched. Got to be sure they don't. So every so often, just stop, look your machine over, because you're flopping that thing around like this all day long. That's what it's supposed to be used for. That's why you need to check your stuff. The other one is heat. If you've overheated the hydraulics, which may not overheat, but the hammer itself might overheat and not show up in the hydraulics so much. Keep an eye on that, on its performance. And every so often, take a temperature gun with you. Well, that's crazy. Yeah, it is. But for $50, $100, beep. Oh, wow, it's hot. Yeah. What's that do? It causes the metals to fracture and go through and ruin your carrier. Because the filters eventually will plug and pop that little bypass. And then they'll go in. The only thing there is the screen. The fines will go through your pump and the rest of the system. All right, there you go. I got to get myself to bed. Hammers and you.